All right, good to have you back. In this lesson, we're going to talk about how we're going to use the five kinematics equations. These are the parent equations, obviously. And then, of course, they're all part of the constant acceleration. All right, we're talking about constant acceleration. All right, the big five equations, these are parent equations, are given right here. I wrote them down for you. And the idea is that every time you come across any given problem, you want to have a list of what it is given to you and then what is that you want to solve, and then match any of these equations that helps you to solve that given problem the easiest way possible. Okay, you do not want to make things more complicated, so you have to choose the right equation. You make sure that the sign convention applies for velocity and acceleration and displacement. Okay, make sure you do that, and then make sure that the unit is consistent throughout the calculations. If it's meters per second, you maintain meters per second. And for the most part, watch out for the final question. For example, it's asking what is the velocity in meters per second. So your unit needs to be in meters per second. Either you do the unit conversion at the very end or you do it right at the beginning, but your choice. Okay, let's go through a few examples. Example one, right here, I have rewritten the five main parent equations on the right hand side, and we're going to just see what we have and we're going to go through it. So first, car accelerating from the rest and is given with some information. The initial velocity, by the way, v0 is in some text they call them vi, initial velocity. That's what that is. And a is acceleration, and that's, by the way, this is meters per second. Acceleration is 3 meters per second squared. That's the unit for acceleration in this case. And time is 4 seconds. Okay, now which of these five equations obviously has to have acceleration, v initial, and we need to know, by the way, these are all given to us, but what we don't have is v final. That's what we don't have. All right, and between the two equations that you're dealing with, the v final is number 2 and number 5. Now be careful with that one. Just the notation, I could have said instead of v equal to v naught plus at, this could have been v final, and instead of v naught could have been v initial. All right, so different ways of writing it, but just be aware. So either one of the two. Which one of the two we can use? Well, this one, because we don't have the distance in here. It's not given to us. It's just time has been given to us. So we're just going to go ahead, and the question is find the final velocity first. So let's find final velocity based on equation number 2. So final velocity v final equals to, so that's what I'm going to use now. All right. V initial is 0 meters per second plus a is 3 meters per second squared, and the time is 4. So RV final will be 12 meters. By the way, 4 is the second. Yeah, that's RV final. Very good. Now, the question is the distance. Can we find the distance? Well, this is very easy. So for distance, we can easily use, instead of number 5, for distance, we can use number 4. Okay, that's the displacement. That's v naught t plus 1/2 at squared. And now we're just going to plug numbers in and then we'll get it. So this is 0. This part here will be, so we have 0 meters per second times t, which is 4 seconds, plus 1/2 times 3 meters per second squared times 4 second squared. And when you do the math, you will get, so you have 16 in here, 16 seconds times 3, that's 48, divided by 2, that's 24, and this part is 0 anyways, so it would be 24 meters. Okay, now let's look at another question. An object thrown upwards. The initial velocity is 15 meters per second, the acceleration negative 9.8 meters per second squared, time to reach the top. Okay, so same idea again, but this time be aware that the V final top is 0 meters per second, right? So it goes up, and at one point it's gonna stop for a fraction of a second. So it goes up and holds for a fraction of a second, then drops. So V final is 0, and then you go back there and you say which of the three, which of the five we can use. And so what do we have? We have initial velocity, we have final velocity, we have acceleration. We want to know what the time is, so we can use this guy again, number 2. Okay, so here it is. We have 0 because final velocity is at the top is 0 meters per second because it's thrown upward. At one point it's going to stop at the very top. So 0 meters per second equals to 15 meters per second. That's the initial velocity, plus a, which is negative 9.8 meters per second squared, okay, times t, and we want to solve for t. Now, you have to either solve this equation for t or do it right here. So when you go ahead, isolate t part of the equation, so subtract 15 meters per second from both sides, so you get negative 9.8 meters per second squared times t. And then now you divide both sides by coefficient of. Now, if you've done everything correctly, you notice that your time should be mathematically should end up being a positive time, which it is. Negative 15 divided by negative 9.8, that will give you a positive value. So your time will end up being 1.53 seconds. Okay, leave it at 3 sig figs with 2 decimal expansion. And then the second question to this one is what is the maximum height? And you can go ahead and use equation number 4. You can use that, or actually you can use equation number 5 too, but equation number 4 is already set up for D. You don't have to solve for anything, and that's just easier to do. All right, so if you rewrite the equation number 4 in here and then plug numbers in, and when you do this, when you set up all the given information, you notice that the V final, it is always 0 in a situation where you're throwing an object up in the air and at one point it stops. So we don't need to use that, and there is no reason to use that. But if you use equation number 5, then you have to use the V squared, the first V, which is V final. You have to set that equal to 0. But anyways, you just plug numbers in now and then go ahead and solve. And when you do all the math, you'll end up getting 11.43 meters. Don't forget, this part will end up being a negative number. Okay, this is a negative number right there because this put right. And when you do this, you just pay attention to what you're doing. You start with 1.53 squared, then you multiply it by negative 9.8, then you divide it by 2, and then of course you have to add the first part. When you do all the math, you'll end up getting 11.43 meters. All right, that's the maximum height. Excellent. All right, I wanted to go over this question, and just understand that at the very top, in a question like this, always the V final is 0 meters per second, because at the very top you'll stop. So suppose this is the ground and this is the projectile, you're dropping it up, and first it goes up. At the very top right here, the instantaneous velocity, so or the V final after initial release, the V final at the very top before dropping down will be 0 meters per second. Okay, always remember that. All right, make sure you check out the quiz. Always, in every video I post a quiz with it as a practice. Check out the next video in this series and practice, practice, practice. Until next time.